Hello class, this is Professor Finan. In today's lecture, it's lecture 2.3, we will discuss random number generators, and we're going to have a few MATLAB demonstration examples. Okay, so let's talk about randomness and random noise. And so whenever we do a measurement, and these are actually both experimental measurements, but also computer simulations. So experimental measurements and to a lesser extent computer simulations, these measurements will always contain random noise or error. And so when we perform regression, the regression should be robust and capable of smoothing out the noise or avoid overfitting to the noise component. And on the other hand, the predictive accuracy of the regression model should not change very much if a different random noise component is added to the training set. So remember, the training set is the data that we perform the regression on. And so there's actually there's some different methods of adding different types of random noise to your data set to assess the robustness of your regression model. One method from maybe the 1970s is called the bootstrap method of residual resampling. Nowadays we have, since everyone has personal computers and we have access to the scientific computing languages like MATLAB and Python, all of these scientific computing languages, they have what are called random number generators. And so it's very easy for us as analysts to generate our own random numbers, okay, or we can generate our own random errors, and we can do this from known distributions. For example, from the uniform we can have uniformly distributed random numbers, or we can have normally distributed random numbers, and we can actually then, if we wanted log normal or any other type of distribution, we could always transform any type of distributed random numbers. And what we can do is we can generate our own random error terms, and we can actually add that to our data set. And this is the way we can test the robustness of the regression model. And so this is a very, I think, a very good way, something that you should apply when you're building your regression models. And so I'm going to just talk about MATLAB today. And so random number generator in MATLAB. And so MATLAB has built-in functions to generate random samples from both the uniform distribution, okay, and that's uniformly distributed on 0 to 1, and also the standard normal distribution. So the standard normal distribution is a one-dimensional Gaussian distribution, mean 0 and variance of 1. And also then, so the first number is the mean, the second number is the variance. And of course the standard deviation is the square root of the variance. And so in MATLAB, there's a command, rand, R-A-N-D, that will return a random scalar drawn from the uniform distribution in the interval 0 to 1. And then the second function is called rand-n, R-A-N-D-n. And this returns a random scalar drawn from the standard normal distribution, so mean 0 and variance 1. And so, and with these two basic random number generators, it's very easy to make random samples from any arbitrary uniform or normal distribution. And so the next two bullet points, these are actually command lines you could type into MATLAB. And so, for example, if you wanted one uniformly distributed sample but uniform between 5 and 9, I'm going to use E for error. So E equals 5 plus and then 9 minus 5, or basically the range of that uniform distribution times rand m 1 comma 1. And so it also, these functions, rand and rand m, the first two inputs, they will generally return a matrix. So if you put like rand 100, it will produce a 100 by 100 matrix with uniformly distributed variables. And so you should designate, sometimes we might, for example, we might want a column vector of random numbers to add to our y values in our data set. So you need to put in how many random numbers you want. For the normal distribution, so this example, this is going to be a normal distribution with mean 1.5 and then a variance of 0.25. Then that means if the variance is 0.25, the standard deviation is 0.5. And so here we have E equals 1.5, the mean value, plus 0.5, which is the standard deviation times rand n 1, 1. So this will return a random sample from this normal distribution. And then, yeah, and if you have some other functional form like log normal or gamma function, you can program your own, for example, the inverse cumulative density function transform. So there's ways then if you need to get random numbers from other distributions. And so let's go to actually MATLAB and just do a quick demonstration. And I've changed the fonts, so here I have, this is the MATLAB, it's version 2018b, and across all the versions, these functions have stayed the same. So first, if you just type rand 1, 1, okay, then I'll repeat it. Let's just keep repeating it a few times. So here we've gotten 0.8147, 0.9058, 0.1270. And so now I'm going to define a new variable. I'm just going to call it x, or let's use e. E equals rand, and let's make a really big, a really long vector. So I will do, let's do 10 to the 6th, comma 0. And I'm going to put the semicolon. If you don't put the semicolon, it will print. Without a semicolon, MATLAB prints the answer to the screen, to the command prompt, command window. So this is going to be a 1 million long column vector. So I'll do the semicolon. Okay, but here in the workspace, let me just increase the font size of the workspace. There we go. So 10 to the 6th, comma 1 gives us the a 1 million long vector. So if we actually wanted to look at the numbers, you know, we'll have a column vector of 1 million of these random numbers. And so to visualize this, we can actually visualize this by plotting. So I'm going to just do the command hist, which makes a histogram of E. I'm going to do comma, and let's do 100. That means we're going to have 100 bins in our histogram. I'll hit enter. And so this is the histogram made by MATLAB. Basically, we have 100 bins between 0 and 1. If you look at this, we did 100 samples. Now these are random samples, so here this is the frequency. So we're at about 10,000. So 10,000 times 100 is 1 million. You can see that this closely approximated uniform distribution. And of course, there is some fluctuation. And let's do it. Let's do this again, but let's do 100 million. And we'll repeat the same thing. But it takes okay, and then let's look at our plot. And so here we've done more, the larger your sample size here, it's almost, you can see there's a small amount of fluctuation. Yeah, so the rand command gives you uniformly distributed numbers. Let's do the example from a uniform distribution between 5 to 9. So we're going to do E equals 5 plus, it'd be 4 times rand n of, let's do the 10 to the 6th, comma 1. And now I will do the histogram. And see, here now our histogram is going between 5 and 9. Okay, so you see we have these uniformly distributed numbers. And of course the axis, the y-axis is the frequency, because this is a histogram plot. Let's do the normal distribution. So we'll do clear all. Let's do E equals rand n of, let's do 10 to the 6th. Well, and then comma 1. And now I will do a histogram. Well, we could actually look at the numbers. So if we actually look at some of the numbers, of course, the normal distribution with mean 0 can have both positive and negative numbers. You can just visualize some of these numbers. And so now let's use the histogram command, and let's look at the histogram plot. So obviously, this histogram closely follows a normal distribution. We did 1 million samples. And of course, this is mean 0. And let me put up the screen so I can, let me draw on this plot for you. Remember, these are normally distributed on 0 to 1. And so obviously, we have the mean 0, so mu equals 0. And with the normal distribution, so the standard deviation, this is -1 standard deviation, +1 standard deviation. So I'm just going to sort of, we can just roughly estimate, okay. And so usually about plus or minus 1 standard deviation on the normal distribution. That's around, I think, 66% of the volume of the probability density function. So that's a confidence interval. And then plus or minus 2 standard deviations. Okay, so this is -2 standard deviations and then +2 standard deviations. That's about this area. Approximately 95% of the distribution. And so obviously MATLAB, this is producing random numbers that are following the normal distribution. So using the scientific computing, it's really easy to generate random numbers. Why don't we just do one more example? Let's do a random numbers distributed from a normal distribution with a different mean and standard deviation. So let's do E equals, let's do a mean of 10. 10 plus, let's do a variance of 15. 10 plus 15, or let's do a variance of 16, so that would be a standard deviation of 4. So 4 times ran n of 10 to the 6th, comma 1. And then let's do the histogram. And so now our mean value is around 10, okay? And we had a standard deviation of 4. And so you can kind of visualize that sort of these numbers are randomly distributed with a mean 10 and standard deviation of 4. Okay, so let's go back to the PowerPoint, and I'm gonna actually, oh, one thing I want you to remember is this number right here. And I'm going to write it down. So when I first turned on MATLAB, I did rand 1, 1, and it gave 0.8147. So I'm going to write that down. 0.8147. So I want you to remember that number, 0.8147. So I'm going to go ahead and close MATLAB, and then let's go back to our PowerPoint. Okay, so now let's talk about pseudo-random numbers. Pseudo-random number generator. So MATLAB is actually not producing true random numbers. It's using a pseudo-random number generator. So what is a pseudo-random number generator? So a pseudo-random number generator is it's an algorithm that generates a sequence of numbers whose statistical properties approximate those of a sequence of true random numbers. And now, so then what is a true random number? A true random number is drawn from a set of numbers that has no discernible pattern for prediction. So the actual underlying pattern must be unpredictable. And each draw is independent from the previous draws. So one example of a true random number would be 1 through 6 from a roll of a fair dice. Okay, so here we have dice, but it's pointing, what I mean by fair is meaning there's no, that when you roll the dice, each one of the sides has 1/6 probability of occurring. And so sometimes in maybe the illegal gambling place, the dice might be weighted, okay? And so those are not a fair dice. So for example, the rolls of a fair dice, those are actually random numbers, especially, and if you rolled the fair dice millions and millions of times, you would have a sequence, numbers between 1 and 6, you would have a random sequence. And so basically these pseudo-random number generators, they produce long strings of random numbers. And so here's an example. It's just, these random number generators, they just produce these very, very long strings of these random numbers. And so now I want to go back to the MATLAB. And so remember I said, remember this 0.8147 number. And I'm going to do something called format long. That will it'll print out more decimal places. And so now I'm going to do rand 1, comma 1. Look at the number. 0.8147236863939179. And also, if you count, there's actually 16 decimal places. That's because on the modern computing architecture, these are called, it's the machine round-off. Basically, we're limited to the 16 digits. And so here, I reopen MATLAB, and this rand command is supposed to give me, it should be a random number between 0 and 1, uniformly distributed. But 0.8147, that was the number we had before. Okay, so and I'm going to write, let's add 0.8147, what is it, 236,6, and there's some more. So let's even add more of those decimal places. And so I'm going to close MATLAB. Now let's reopen MATLAB. Let's do the same thing. Format long, rand 1, comma 1. Look, 0.814723686393. That was the exact same number we had before. And so now let's do a little bit different experiment. I have another laptop here. And I'm going to I'm gonna plug this laptop into the PowerPoint. Okay, so this is a different laptop. Where's Matt? Let's go to MATLAB. And this is version 2021A. Let's wait till it load. So let's do format long, and let's do rand 1, comma 1. Look, this is a different laptop. If you can see, I changed, there's 2 laptops here. There's 2 laptops. This is a new laptop. Even different version of MATLAB. Version 2021A. 0.814723686393. Same number as before. So let's close. And so let's reopen again. I'm going to do rand, and I'm going to do 4, comma 1. So this will produce 4 random numbers. But here, see, our first number was 0.8147. It's that same number again. And let's do here. We have 905. Let me write these down. Then we have 0.905791. And we have 0.12698 and 0.91337. So those are our first 4 random numbers. And so I'm going to close this one. Let's go back to the original laptop. Okay, so class, so now here we're back to the original laptop. This is that version 2018B MATLAB. And I've just opened the command window, so let's do rand 4, comma 1. And see, we get 0.8147, 0.9058, 0.905, the next 79, that rounds to 8, 0.1270, 0.9134, 0.9134, 0.26, or 0.270. And so I thought I just told you these are supposed to be random numbers drawn from the uniform distribution and the normal distribution. But every time we open up MATLAB, it's giving the exact same sequence of numbers. And so this is an artifact that it's the pseudo-random number generator. And so, and let's go back to the PowerPoint. Okay, class, so we've just observed that every time we open MATLAB, it keeps producing the exact same sequence of these supposedly random numbers. And that's because we're using pseudo-random number generators. And these generators, they're generating a sequence of numbers whose statistical properties approximate those of a sequence of a true random numbers. And so with random number generators, there's something called the seed or the random seed. And so these random number generators, it's a mathematical algorithm. So there's an integer value that initializes the calculation. And I think the default random seed is 1. But you can using a command called RNG, which is the random number seed, you can input a different seed number, and then you will create a different string of pseudo-random numbers. And so where the seed number is some integer which sets the seed number from which the algorithm initializes its calculation to the generator of the random string. Okay, class. So now from the previous demonstration, we know that the scientific computing languages like MATLAB use pseudo-random number generators. And so when you turn on the program, there's going to be the default settings. And so when you're performing a statistical study and you want to first generate some of your own, let's say, random error terms to test your regression methods, you should always set your random seed. And also what's useful about this approach is you should save your random seed number in your input file that you're running your regression model with. That way, if you need to go back and reproduce results, you can do that with the same set of random numbers. And so what I usually do is I always set the random seed number at the top of my input file. And I usually just, there's a few different ways that you can set the random seed number. One way to do it, I just sort of close my eyes and I just randomly press a few numbers on the keypad. Or you can devise your own ways of using your random number generator. Yeah, so you should devise some sort of simple way to set your random seed. And so, for example, if you have online banking and you have the little password generator, okay, which you could actually use, for example, your OTP password number. Because it's always changing every 30 seconds. You can use that as your random seed. But you should always save that random seed number in your input file. So if you need to go back and redo some statistical analysis, this could be months, maybe even a year later, you'll be able to generate the same string of random numbers. Another way, you can just use the default setting. I don't necessarily recommend this, but the second way is you always use the default seed, but when you just turn on the program, you can just generate a very large number of random numbers that you don't even need to store. Just execute the random number generator. That way it moves the number generator deep into the string of random numbers. And so let's go back to MATLAB and let me just demonstrate. And so here I've just turned on MATLAB again, so let's do our rand 4,1. Okay, see it has those four same numbers, 0.8147, 0.9058, 0.127, 0.913. So now I'm going to change. I'm going to do RNG, and then if you pressed a few random numbers, well let's do seed number 500. and let's do rand for n. So now we've changed, so now if we change the random number seed to 500, if we do the rand command and we get 4 random numbers uniformly distributed between 0 and 1, we get 0.6937, 0.0617, 0.666, 0.5592. Now I'm going to repeat again. Now it's 0.058, 0.05851, and so on. So now if I do RNG 500 again, and then generate my 4 random numbers, see, it goes back to the original, 0.6937, 0.6937. So here, let's do it. Now let's do RNG 501. So we've changed the random seed again. I'm just going to do rand 1, 0.0275. Now let's do RNG. Let's change it back to 500. And let's do our 4 digits. See, 0.6937, 0.067, 0.666. You see? So you can always go back and reset your random number generator. So, but once again, if we did 1,000,000 samples and we made that histogram, those would still be uniformly distributed numbers. But it's just the actual sequence of numbers will be identical because we're using the pseudo-random number generator and we're using a particular seed number to initialize that mathematical algorithm. Yeah, so that's the final aspect of the random number generator lecture.